picture this. You're standing at the edge of a vast, completely uncharted cosmic ocean. For nearly a century, we've navigated these waters using a trusty map, our standard model of physics. It told us the universe is smooth, balanced, and totally predictable on its grandest scales. But out there in the dark, shadows are moving. Giant, seemingly impossible structures are breaching the surface of our awareness. And honestly, they're shattering the quiet confidence of modern astrophysics. Today, in this explainer, we're journeying to the absolute edge of our understanding to unveil a revolutionary, cinematic blueprint of reality itself.
It's a pretty heavy question, right? Pinning our entire understanding of the cosmos onto a single what if. But guys, we are reaching a real breaking point in modern science. We're finding things out there, deep in the universe, that simply should not exist according to our current models. So what if the foundation of everything we know about the structure of reality is just fundamentally flawed? What if we're only looking at one tiny facet of a much grander, hidden geometry?
The tension in the scientific community right now is absolutely palpable. Cosmologist Alexia M. Lopez, who actually discovered some of these impossible structures herself, hit the nail on the head. She said, "These oddities keep getting swept under the rug, but the more we find, we're going to have to come face to face with the fact that maybe our standard model needs rethinking. We just can't ignore the anomalies anymore. We can't brush them off as statistical flukes. These anomalies, they are quickly becoming our new reality."
Now, before we start breaking the rules, we have to understand them, right? The absolute bedrock of our standard model is something called the cosmological principle. Basically, this is the assumption that when you zoom out far enough, the universe is isotropic, meaning it looks the exact same in all directions, and homogeneous, meaning matter is evenly distributed. Think of it like a perfectly blended bowl of soup. Sure, you might have a clump here or there close up, but overall, it's uniform. According to this principle, there is a hard, theoretical size limit for structures in the universe, capping out at around 1.2 billion light-years. Anything larger than that, it simply shouldn't be mathematically possible. But here's the thing. The universe is completely ignoring our math. Just look at these colossal cosmic rebellions. We've got the boss Great Wall, which is an incredibly dense complex of superclusters. Then there's the Large Quasar Group, a massive filament of highly active galactic nuclei, and the absolute heavyweight champion, the Hercules Corona Borealis Great Wall. This structure is so unfathomably huge, it stretches across roughly 10 billion light-years. These aren't just minor deviations, folks. These are massive, complex systems that make our standard model look like it's literally bursting at the seams.
And then there's the giant arc. Discovered by Alexia Lopez's team, this staggering structure spans 3.3 billion light-years. Just to put that mind-boggling number into perspective, that is roughly 1/15 of the entire radius of the observable universe. If you could actually see the giant arc glowing in the night sky, it would take up the space of 20 full moons lined up. Structures like this are supposed to be impossible, yet there it sits, a massive curve of galaxies and gas directly mocking that 1.2 billion light-year limit we just talked about.
And it's not just these megastructures that are rebelling either. Individual galaxies are throwing a wrench in the works too. Take NGC 1052-DF2. This is what we call an ultra-diffuse galaxy, meaning it's huge but incredibly transparent. But the real kicker here is its dark matter, or rather, the complete lack of it. Kinematic analysis of its globular clusters shows its mass falls a factor of 400 below canonical relations. Dark matter is supposed to be the invisible scaffolding holding every galaxy together, right? Yet DF2 is practically naked. It formed super early, roughly 5 billion years ago, and somehow just completely skipped the dark matter assembly line.
Even the shapes of galaxies are throwing us curveballs. Enter the ring galaxies. These are a genuine 1 in 10,000 cosmic rarity. Unlike your common spirals or ellipticals, ring galaxies, like Hoag's object or ARP-147, feature an older elliptical core completely separated by a massive gap from an outer ring of brilliant young blue stars. They are stunning, highly unusual, and they point to incredibly rare evolutionary pathways, like direct bullseye collisions between galaxies, that completely challenge our conventional understanding of how cosmic structures settle.
And it's not just about size or shape. Things are actually moving the wrong way. Our standard model predicts that large-scale motion in the universe should decrease at ever greater distances. It should all just average out. But cosmologist Alexander Koshlinsky and his team detected something called dark flow. They found that vast swaths of matter are moving at a constant, non-decreasing velocity out to at least a billion light-years. Why? Well, it seems they are being pulled by something incredibly massive that sits entirely outside of our visible universe.
Theoretical physicist Dr. Sabine Hossenfelder lays out the mathematical reality of this perfectly. She notes, if you assume that the cosmological principle is valid within a particular theory, then you can calculate the distance at which averages should all be equal. But as we've just seen, the averages aren't equal at all. The giant arc, the massive quasar groups, the dark flow, they entirely refuse to smooth out. It forces us to take assumptions underpinning our entire framework are actually just an illusion.
So this really brings us to the precipice. With standard physics struggling,
endlessly patching up holes with invisible dark matter and dark energy, and totally failing to explain these massive structural anomalies? Do we need an entirely new cosmological architecture? Not just some minor tweak to the equations, but a fundamental paradigm shift in how we view the very genesis of reality?
A new origin, the tetrahedral universe.
The foundation of this radical new architecture is called Physical Information Cosmology, or PIC for short. PIC argues that the so-called quantum vacuum at the very beginning of time wasn't just empty space waiting to explode. Instead, it was a primordial sea of pure physical information existing in a free potential state. In this framework, the birth of the universe wasn't some random chaotic Big Bang. It was a highly structured, recursive condensation process, kind of like water freezing into perfect geometric ice crystals, driven by the strict conservation of information and energy.
This creation process breaks down into a two-stage fundamental transition. First, that sea of physical information bifurcates, meaning it splits evenly into positive and negative energy foundations. This elegantly solves the long-standing energy conservation problem. Second, those energy domains condense and bifurcate again, ultimately solidifying into actual isolated material universes.
Let's break that down. At the very top, we have that primordial physical information. When its potential reaches a critical threshold, it undergoes a symmetry bifurcation. It splits directly into a positive energy domain and a negative energy domain. This is a massive conceptual leap here. Energy and matter aren't the fundamental building blocks. They are secondary realities that actually emerge from physical information. Then, in the second stage, those positive and negative energy domains split again. The positive side creates our universe, which we'll call U1, along with a positive antimatter universe, U2. The negative side splits into a negative matter universe, U3, and a negative antimatter universe, U4. Now, to prevent these radically opposite universes from immediately colliding and completely annihilating each other, they instantly established a recessional motion relative to each other at the speed of light. This creates what's called a dual causal isolation, keeping all four universes perfectly safely separated.
So you've got four distinct universes expanding away from each other. How do they balance out? Well, they naturally arrange themselves into a regular tetrahedron in higher dimensional spacetime. Think of a 3D pyramid with a triangular base. Just like the tetrahedral shape of a methane molecule perfectly balances the repulsion of its electron clouds at the lowest possible energy state, these four universes perfectly balance their mutual gravitational and repulsive forces. And get this, we live on just one single node of this colossal cosmic tetrahedron. This single, elegant geometry suddenly solves our biggest mysteries. First, it explains the exact speed of light. C isn't just an arbitrary cosmic speed limit. It is the physical baseline speed at which our universe is structurally expanding away from the other three. Nothing inside our universe can move faster than the architecture itself. Second, remember that dark flow being pulled by something outside the visible universe? This model says that something is the gravitational pull of universes U2, U3, and U4. And third, the giant arc and those great walls, they aren't random at all. The forces from those other universes act as an externally architecturally driven field, literally stirring our cosmic web into these massive, deliberate, non-random filament structures.
Talk about a breathtaking paradigm shift. We move from a chaotic, isolated bubble filled with inexplicable anomalies to a highly structured, perfectly balanced tetrahedral universe, where every single anomaly is actually a vital clue. So as we wrap up this explainer, I want to leave you with this provocative thought. If our observable universe is really just one point on a massive cosmic tetrahedron, what other signals from our three sister universes are washing over us right now, just hidden in the data, waiting for us to finally open our eyes and decipher them?